Well, thanks for having me. It's an honor to be here. And the title of the talk is controversial and provocative in purpose. And I would actually like to begin by explaining where the title comes from, because it is directly connected to the content of the talk. It all began with a little bit of a concern that I have. So it is true I have been working for the news industry for more than 20 years. I have actually two careers at the moment. So I am both a professor at the University of Miami, and in parallel I also keep producing data visualizations and infographics and animations and 3D models and things for clients and of many kinds, like business, different kinds of businesses and institutions. These are several screenshots of several graphics that I produced in the past during my career as a journalist, but I keep doing this work. But the concern consists of these. I am part of several communities that produce this kind of work. So on one hand, I am friends with people who produce graphics and visualizations for the news industry. I still keep working with people and being friends with people in places such as the New York Times, the Washington Post. Several ex-students of mine work for these places. I have many friends in ProPublica. You have already heard about ProPublica. You should all follow that organization because it's absolutely wonderful and they produce great information visualizations. 538 and Vox.com, all those places. I have all friends in all these places, and I am part of that community, of the community who uses data, and in particular graphics to communicate with the public. So that's one side of my career. On the other hand, I am also a professor. I also work in an academic environment at the University of Miami, and besides teaching at the School of Communication in the Department of Journalism, I am also part of a Center for Computational Science, right? In which I help, scientists from different fields to visualize information and communicate that information a little bit better, perhaps, right? Here you have a couple of photographs of one of my bosses just presenting a new visualization lab that we have opened recently at the University of Miami, which has 3D capabilities and VR and all these wonderful technologies. I also collaborate with Google in a series of experimental data visualizations in which we try to visualize data in creative ways, to try new things, and we are developing new tools to create visualization that scientists and journalists can use for free. I am friends with people who develop new ways of visualizing data, people such as Stephen Few, for example, who created the bullet graph, which is a way to condense large amounts of data in a very small space. So on one hand, I am part of communities who are trying to push visualization forward, creating new tools, creating new ways of showing information, etc. I am part of that dialogue, right? But throughout the years, I have, particularly in the past 4 or 5 years, I have started being concerned about whether we are not leaving the general public a little bit behind in the sense of, the tools that we create, whether they are well understood by the general public, by all the general public in general. And the sources for my concern are varied. I'm going to share a few of them with you. One of them was, for example, a survey that the Pew Research Center conducted in 2014, asking us, I believe that it was a sample of 1,000 people, whether they could use that chart, right, and what they got from that chart. And it's your more traditional scatter plot, right? Horizontal axis is average sugar consumption, grams per person per day. Each one of the dots is a country. And then the y-axis is the average number of decayed teeth per person in different countries. So obviously there's a direct relationship in there. The more sugar you consume, the more decayed teeth you have, right? Which is pretty obvious, right? That's what all of you read, right? All of you interpret. Well, unfortunately, only 63% of the people who answered to this survey got the correct answer. The other 37% didn't get the notion, didn't get the idea of this chart really well. They saw, for example, things such as change over time and things like that. So they misinterpreted the graphic by far, right? But quite a lot. This is highly worrying, and the reason why it's highly worrying is because if you're aware of the history of data visualization, and I am, because that's about the only thing that I can teach with any sort of authority, The scatterplot is a graphic form that has existed for more than 150 years. All right, so the scatterplot is a graphic form that was originally used by people, for example, such as Sir Francis Galton in the 19th century to show the relationship between height and head circumference and things like that, right? That's an image of one of Sir Francis Galton's scatterplots, one of the earliest examples of scatterplots. That means that in more than 150 years, 37% of the American public has not been able to adopt the grammar, to understand the grammar and the vocabulary of a very, very basic graphic form. And that's highly worrying on one hand, right? Moreover, it is worrying because we also have evidence that shows that even if a portion of the public doesn't understand some kinds of statistical graphs and maps and numbers really well, they are still persuaded by those numbers. So there are several research projects that have been done throughout the years that show that they do an A/B testing, so to speak, right? So they get two groups of people. To one group of people, they show a message, some sort of message that tries to be persuasive, only using words. And to the other group, they show the same message, the same persuasive message, with the same words, but inserting numbers, graphs, maps, etc. Well, by far, the second message, the one that includes images and numbers, is far more persuasive than the former, than the previous one. Dangerously so, because some of these research projects have also shown that it doesn't really matter that the chart that you include in your document has anything to do with the content of the document. As long as you put a chart in there, the message becomes scientific. It looks scientific. There's some sort of wiring inside our brains that leads us to believe that whatever includes numbers, whatever includes charts, that's much more objective and much more real and much more truthful than something that doesn't have visuals. So we have the perfect storm over here, I believe. On one hand, we have a substantial portion of the population who doesn't read numbers and doesn't read graphics well, and on the other hand, even if they don't read them well, they are persuaded by those numbers, right? So, throughout the years, I have come to believe that whenever we talk about data dialogues, in general, we tend to speak to each other. I talk to you, you talk to me. I work with data, you work with data. And we should keep doing this, right? We should keep talking to each other to develop new techniques. I'm not arguing against developing, 3D VR technologies, for example, to explore virtual environments or to visualize data in virtual environments or whatever. We need to keep working on these new methods. We need to keep developing Python libraries, or if you are an R person, I am an R person, so developing new R libraries and stuff. We should keep doing that, right? But at the same time, perhaps we can all contribute a little bit to talk to the general public. And that's what the lecture is about, right? So how can we help that 37% of the public to understand data and the visual representation of those data in particular a little bit better? So where does the title come from? I have been thinking about this talk for many years right now. Right after I published my second book, The Truthful Art, I started thinking about how I could bring those ideas to the public and explain them in a language that a normal person could understand. And the original title of this talk was Graphicacy. Right? Graphicacy basically meaning visual literacy or graphical literacy, right? There is an author in cartography called Mark Momonier who in one of his books talks about the 4 different skills that an educated person needs to have nowadays. The first one is obviously literacy, which is the ability to read and write correctly. The second one is articulacy, which is the ability to express yourself well using words, spoken words. The third one is numeracy, which is not statistics alone. It's more the skill of thinking critically and to reason with numbers and scientific evidence. And then the fourth one, which is the one that I care about the most and the content of this lecture, is graphicacy. But talking with friends, they told me, if you title a talk Graphicacy, you will attract a very specific kind of person, right? You will only attract the nerds, and which is fine. I love nerds. I am a nerd myself, and I love you all. But I also want to, I also want to attack other kind of people, right? So I am opening this lecture as part of a series of lectures that I'm doing all over the country. And my goal is to attract not only the nerds, but also perhaps people from the general public who may embrace the ideas that I'm about to present in a very brief way. So I started toying with different names for the talk until right after the 2016 presidential election, someone on Twitter, and I cannot credit this person because I don't remember who it was, someone on Twitter tweeted the meaning of the word Trumpery. And the word Trumpery is a splendid word of the English language, because the original sense or the original meaning of the word Trumpery is to deceive. It's something that deceives the eye. It's something that deceives the eye, and also, more modernly, it's something that is worthless nonsense. So I said, this is fantastic. It's a great word for several reasons. First of all, because it will help me provoke people. Right? It will help me bring more people to the talk, thinking that perhaps they are going to hear a rant against politicians, and that's not what the talk is about. And second of all, because it is directly connected, that fact that I'm trying to trigger people to believe something that is not so, is directly connected to one of the pieces of advice that I give people when they want to see a graphic. Never read the title alone. Go beyond the title and see what the actual content of the graphic is. Because if you don't do that, if you don't read the graphic carefully, you will be misled. Before I show you one graphic that misled 37% of the public, that Scatterplot, right? 37% of the survey couldn't read it correctly. Let me show you another one that barely anybody or almost nobody reads correctly, even if it is very common. Living in Miami, I see that map every year, right? This is the map from Irma, showing you the possible path of Hurricane Irma over Florida, all over Florida, right? Commonly, that's the common name of this kind of map is the cone of uncertainty, right? Although down there in Miami, we usually call it the cone of death, right? We like to be dramatic in there. This map is highly problematic. This kind of map is highly problematic. So let me explain why. In order to explain you why, by the way, I'm not going to use a real map, right? I'm going to use a fictional map that I created for the sake of clarity to illustrate the problems that the map has. I created a hurricane with my own name, my last name, and obviously that hurricane needs to be a category 5, right? I cannot be a category 1, so category 5, right? So we have Hurricane Cairo about to hit the southern coast of the United States, right? And we have that cone, right? For those of you who don't know how this map is generated, it's actually quite simple. Explaining in lay terms, what scientists do is to predict more or less where the hurricane is going to go, and then they surround those point estimates with circles of increasing sizes, because obviously this is a forecast, so the further away you go from the present, the bigger the uncertainty of the data becomes, right? The way to read this map, right, the cone of uncertainty, is that then basically the hurricane could go over here, right? Or it could go over here, or it could go over there, or it could go over there, over there, over there, over there. The center of the hurricane, okay? The center of the hurricane. Right? That's how you read this map. That's how you should read this map, right? That is basically showing you the possible range of possible paths of the eye of the hurricane, right? But that's not how some people read this map. Several research studies have shown that certain people, not everybody, but certain people, when they see the cone of uncertainty, they see the size of the hurricane itself. Now, very important to remember, we tend to laugh at this point. I get some laughs. How can people be so stupid, right? Well, that's not the problem. The problem is not that people are stupid. The problem is that the graphic form itself has a pictorial resemblance with the actual shape of a circle, which is usually the shape of a hurricane, right? Circling around, right? So that's not how you read the map, right? Obviously, you should read it as the possible paths of the hurricane, right? The thing is that so all of you should be aware of how to read this map correctly, but probably what you're not aware of is what is the probability that the hurricane will go inside the boundaries of the cone of uncertainty. That was my assumption. The first time that I saw a cone of uncertainty, I said, well, I guess that what scientists are basically telling me is that 95% of the time that we get a hurricane with these exact features, 95 of those hurricanes will be anywhere within the boundaries of this cone of uncertainty, and 5 hurricanes, the outliers, may go outside, right? So that's not true. That's not true. based on past rates of success and past rates of failure in predicting where hurricanes could go, the probability is 66%. How many of you were aware of this fact? Right? I live in Florida. This scared the hell out of me, right? Because basically, what this map is showing you is something like that, right? It's like a much broader range of probabilities, right? And even it is even scarier if you remember that. That is only showing you the path of the center of the hurricane, but a hurricane is a very big thing. So that thing is actually showing you something like that, right? Now the challenge is that if you show that to the general public, you may get some pushback, right? So, you know, scientists know nothing, right? Which is actually true, right? We know nothing. But sometimes, I don't know, this is just several ideas that I've been toying with about how to improve hurricane communication. It's one of the projects that I'm involved in at the University of Miami. So we're still developing some, you know, thinking about new ways of communicating hurricanes. One of them will be perhaps to communicate a more clear message of what to do. Screw uncertainty. Just tell me what to do. Anyway, so even very common graphics that we see every single day can be misinterpreted very easily. By the way, let me make an aside. The fact that this map is so popular is not because of the National Hurricane Center or NOAA. NOAA and the National Hurricane Center are trying to discontinue the cone of uncertainty, and they are trying to push other ways of presenting hurricane probabilities. It is the media who loves to use these maps because they look so clear-cut, right? They look so clean, right? There's no probability in there, it's just the cone of uncertainty, but everybody misreads it, right? Now, I have also started observing how certain media organizations on the right and on the left, on both sides, are weaponizing data, right? And try to, weaponize is a word that I don't like to use, but are using data to push agendas, basically, right? So let me show you an example. This is a story that comes from Breitbart.com. A while ago, Breitbart published this story that was quite alarming. They said, 2,139 DACA recipients convicted or accused of crimes against Americans, okay? And the introduction to this story said, the number of DACA recipients, you remember that DACA is the Deferred Action for Childhood Arrivals, which is a plan that protects undocumented immigrants that arrive to the United States, brought to this country by their parents when there were minors, and this program protects them, okay, against deportation, for example. Anyway, what Breitbart was saying is that the number of DACA recipients who are convicted criminals, gang members, suspects of crimes, and therefore have lost their status of DACA recipients because of that is staggering. It's 2,000 people, right? I said, well, it's staggering, that's for sure, but perhaps it's not staggeringly high, it's actually staggeringly low. Because if you take a look at the number of DACA recipients that we have in this country, it's 800,000 DACA recipients. So I'm not very good at doing mental math, I am more like a visual person. So I created that very simple visualization to show you the evidence, right? I like to create low-tech visualizations to visualize data, to basically wrap my head around numbers, because 2,000 and something people out of 800,000 is 0.263 something percent. You're all mathematicians, I am not, I cannot understand that number. So I need to transform those numbers into some sort of physical number, right? Such as less than 3 out of 1,000 DACA recipients have lost their status because of a criminal conviction or an accusation of being criminals. Now, you know what that number is among general Americans, among American citizens? 64. So basically what Breitbart's story is telling me is that DACA recipients are far less dangerous than Americans themselves. So the number is staggeringly low, in my opinion, right? Now, this is the kind of reasoning that I believe that anybody, regardless of background, regardless of statistical knowledge, can do. This is just basic arithmetic. It's just a matter of, very important, and that's the first piece of advice that I give everybody, related to not to you, but to the people we can talk to help them educate or help them learn about these topics. The advice that I give them, read beyond the title and read the story. Don't keep just the headline, read beyond the story. So the advice that I give people consists of several points that I'm going to outline very briefly with a very, very quick example for each one of them. How not to be misguided by data and visualizations. First of all, there is some responsibility on the part of the reader, and then there's some responsibility on the part of the designer. Now, the readers in general, need to get used to pay attention. That's the first thing. You will not be able to avoid being misled by a visualization that is based on data if you don't read it. That's the reason why you need to read beyond the title. Visualizations, and this is a very important point to emphasize with people who are not used to creating graphics on a regular basis, are not meant to be seen. They are meant to be read. And many people out there, in my industry, for example, in journalism, who believe that visualizations are illustrations. They are just beautiful pictures. And I say, well, this is not true. This is a piece of text, and you need to treat it as if it were a piece of text. It has a grammar, it has a vocabulary, it needs to be read, and it needs to be interpreted. Second of all, notice what the visualization shows, but also try to think about what the visualization is not showing or maybe hiding, because both things are important. A visualization is a model of reality. No model is perfect. Some of them are useful, some of them are not that useful. And connected to that, a visualization is a very, very important that we can try to emphasize. A visualization shows only what it shows and nothing else. Because people, in general, and this happens to everybody in this room, to myself and to everybody else, we usually tend to read a little bit too much from the graphics that we see in the media or in publications in general. Let me show you one of my favorite examples. It comes from a wonderful book titled Teaching Statistics, A Bag of Tricks by Andrew Gelman and Deborah Nolan. So in this book, they have this visualization over here, a very simple map that shows you the counties in the United States with the lowest kidney cancer death rates. I can assure you that if a journalist like myself sees this map, the brain will start making up stories like crazy, because we will see that map and we'll notice that most of those counties are rural and sparsely populated, right? And we will start making stories in our mind. Okay, so let me just verbalize what will happen inside my brain. Okay, so all these counties are rural, so perhaps kidney cancer rates are so low because, well, people exercise more, right? Probably they walk more. They have more friends, so having more friends may help you, get less cancer. They probably eat better because they are rural counties. They probably, grow their own food, or they buy, organic food from the local market, so they eat a little bit better. These are the kinds of inferences that your brain starts making automatically when you only see that graphic. And that graphic is not showing any of that. That graphic is just telling you, these are the counties, they are rural. Well, that's not even something that the map shows you. That's something that you know when you come to this map. Now, let me show you, and this map also shows something, but hides something else. Because we could also show what are the counties that have the highest cancer mortality rates, and all of them are rural and sparsely populated. All of them, or most of them. What's going on over here? Which is basically variation, right? All these counties are rural, sparsely populated, and obviously if you have a county in which you have 10 people, right? Suddenly one year you have one person having cancer, and suddenly you have a rate of 10%, right? So basically small samples vary more than bigger samples, right? So that's what's going on over here. So a visualization shows only what it shows, and a reader needs to be attentive to these kinds of problems. On the other hand, designers of visualizations, we should also be attentive to several features that we need to include in our graphics, and we need to get used to receive demands from people for all those 4 points. So in the morning, for example, there were discussions about how media organizations such as ProPublica are making their data public, publishing all that in GitHub, etc., etc. I believe that that's something that more media organizations needs to do. More people need to disclose these data so readers can take a look at it. But here's the problem: if you only put all your data on places like GitHub, only nerds will take a look at it, right? So you need to explain your methodology in plain language, in a language that normal people can understand, something that is devoid of jargon. And if you need to use jargon, explain what the jargon is, okay? Explain what that means, right? So in my books and in my talks, I have several examples of how problematic it can be if you don't disclose the data or if you don't explain the methodology of the data. This is just one of them. So this is a case that I describe in my second book, The Truthful Art, which is a comparison of IPV rates without the metadata. The IPV is basically the intimate partner violence rate in different countries. Okay, so here's what you are seeing. This is the percentage of people who have experienced violence in their families in Cameroon according to different sources, okay? Source number 1, source number 2, source number 3, source number 4, right? So why does it vary so much, right? Well, you will not learn why different sources report different rates unless that you read the methodology and they tell you what it is that they are counting. What is it that they are counting? Because some of these sources are counting things such as, for example, verbal violence, and some of the sources are not counting verbal violence, they are only counting physical violence. So obviously, if a source is counting verbal violence and the source next door is not counting verbal violence, the rate is going to vary a lot. And that's the reason why the methodology needs to explain that in a very, very clear manner and in a language that a normal person can understand. That's our responsibility when we are going to inform the public. What is it that we are counting, how we are counting it, the limitations of the data, all the things that you put in a research paper, but try to explain it in a language that I can understand. I am a normal person, okay? Well, not that normal, but semi-normal. The second one is trying to represent the data well. So the whole idea of showing the right data and then represent it proportionally. The whole idea of data visualization is the proportional representation, the proportional visual representation of data, right? So you have a bunch of numbers, you can represent those numbers proportionally through the length of different objects, like in a bar graph, or through the size of different objects in a bubble chart, right? We call those things methods of encoding. And that method of encoding needs to be proportional to the data that you're representing. Now, in some cases, data is not well represented. Sometimes we represent the wrong data set and we represent it wrong, right? So I'm going to show you a very, very recent example. This is a map that hangs on the walls of the White House. So this is a photograph that was taken by reporters in the White House, and apparently that map hangs on the walls of the White House, showing you the results of the recent presidential elections, who won on each county, right? Red is for Republican, blue is for the Democratic Party. President Trump is very fond of this map, so for a while, this is Photoshop, but it corresponds to reality. For a while, I'm not picking on President Trump. Let me get to that in just 1 second. For a while, President Trump printed out copies of this map, and he handed out copies of this map to reporters coming to the Oval Office. Okay, so this is what this Photoshop picture is representing. Because he's very proud of his victory. He should be. He won against all odds, basically. But what I would say to President Trump is that he's been misguided by the map. He's been misled by the map, because what he thinks is that he won by a landslide, because that's exactly what the map is representing. If you take a look at what the map is representing, if you remember the idea of data visualization, proportionally representing some sort of data set, if you take a look at the sheer proportion of red versus the sheer proportion of blue, that's 80% of red versus 20% of blue. So it's not an accurate representation of the data, because you're not counting the right thing. You're not counting people, you're counting counties, all right, which is the wrong metric to use if what you want to do is to inform the public about what happened in the election. So other than doing that, we could do something like that instead, right? So that map over there is a proportional symbol map in which the circles over there are colored to the win according to the winner, and then the size of the circle is proportional to the number of people who live on each one of these counties. Let me tell you, I have friends who are conservatives, friends who are liberals. Conservatives tend to love this map, and liberals tend to love that map. Why? Because both of them confirm our own assumptions and prejudices, right? If you're a liberal, you will want to show that map, because you say, well, the popular vote, right? And conservatives will tell you, well, the popular vote doesn't matter that much. Let's show the counties. Both of them are wrong, right? Because neither counties nor the popular vote really matters when you're talking about a presidential election. What really matters is the electoral vote, right? That's what really matters in an election, right? That's what we really need to represent. How many electoral votes each one of the candidates won, and where, right? Which states each one of the candidates won. So that would be the right metric if what you want to represent is the results of the presidential elections. At least show that kind of pie chart first, right? How many, And then show me the rest if you want, right? The popular vote, the county level vote, but don't show just that and don't show just that, because neither of the metrics is as important as that number down there if what you want to find out is what happened in the election. Show the right amount of data. What is the right amount of data? The right amount of data is basically an amount of data that is enough for a common person to understand what's going on. That's a very subjective decision. It's trying to find out what's the right amount of data. But you know, it's a subjective decision that all of you, knowing as much as you do about data, can take, right? So let me show you just a very, very, very simple example of what I mean by showing the right amount of data. So this is the US murder rate in the past 50 years or so, 50-something years, right? The US murder rate. It went up during the 80s and the 90s, and then it went down sharply during the 2000s, and then in the past year, a couple of years, it has gone up again. Now, this chart is perfectly fine. There is nothing wrong with it. Mathematically speaking, and in terms of the data collected, etc., it's a good representation of the data. Now, is it a good amount of data? I would argue that it is not, because it is not taking into account the effect of outliers. Right? This is an aggregation of data. It's like you're getting all the murders all over the United States, you're aggregating all those numbers into a single metric, the murder rate. I'm not arguing that you should not show this. You should show it. But at the same time, you need to also show the exceptions. In this particular case, as this story explains with a lot of detail, the effect of those exceptions, those outliers out here, skews the data. If you remove the outliers, actually the murder rate remains more or less the same. It is certain neighborhoods in cities like Chicago, Milwaukee, Miami, and other big cities that are bringing the murder rate up. So both pieces of information are relevant if you want to inform the public about what's really going on. You need to show the murder rate, the aggregate, but then also discuss the exceptions. Both of them are important, again, if what you want to show is a truthful representation of what's really going on with the murder rate in the United States. And this is the way also you can explain it to a person who doesn't deal with data every single day, to always demand more information so they can get a clearer picture of what's going on. And then finally, asking yourself whether the uncertainty of the data is relevant to understanding the story. In some cases, it is absolutely necessary, and then we need to show it and take it into account. I'm talking about journalists in general, that usually we do a very bad job at this. So let me show you an example of these. This is a headline that was published by the most important newspaper in Spain, the equivalent of the New York Times in Spain, called El País, back in 2014. Right? The title says, Catalan public opinion swings toward no for independence, says survey. You know, probably you have read about what's going on in Catalonia right now. A substantial portion of the population of Catalonia wants Catalonia to become an independent country. The other half of Catalonia doesn't want Catalonia to become an independent country. So there's also sort of a standoff in there, and the government messed up and blah, blah, blah. I'm not going to get into that. The thing is that this headline looked dubious to me when I read it, because the title says that, and then the introduction says, for the first time since Catalan leader push for independence, blah, 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 a survey shows that a majority in the region would reject secession if a referendum were held now. Remember that this was published in 2014. The data comes from a survey that the Catalan government publishes every single year. So there's a time series in there that you can analyze. And it is true that the support for independence has gone down slightly in the past few years. But is it true that the no is bigger than the yes? Right? That's the question that the title was addressing. The title was very explicit, particularly its Spanish version was very explicit. The no to independence is bigger than the yes to independence. And they show that with that graph, right? So do you want Catalonia to become an independent state? That was the question in the survey. 45.3% of the population said no, 44.5% of the population said yes, 10% of the population said no answer. Well, there are several sources of uncertainty that are incredibly important. The first one, even if you don't talk about confidence intervals, all these people in the 10% will end up voting for either no or yes, so, and you don't know where they will go. But moreover, if you read the story itself, if you read beyond the title, right, we should encourage people to do that, and you get to the, I believe at the end of the first or second paragraph, you will read that the confidence interval at the 95% level, the margin of error is 2.95. So, what is actually being represented in these is something like that. The problem with methods of representation such as the bar graph and many others that we use every single day, the same as the cone of uncertainty, the boundaries of the objects that we use to represent the data are sharp and clear-cut, right? And they should look blurry. I'm not saying that we should blurry the edges of objects, but we can help people visualize that blurriness in their minds. Whenever you see a bar graph that looks clear-cut, imagine that there is like a cloud of uncertainty around that. And if that cloud of uncertainty is much wider than the difference between those 2 points, particularly those 2 points are close to 50%, you cannot really tell whether the no is bigger than the yes or the yes is bigger than the no. All that you can say is that no and yes appear to be tied. That's what you can say in the title. So just as a reminder of all these 4 principles that perhaps we can all help, I believe, spread among the general population, let's teach people to demand media organizations to disclose the data and discuss the methodology in plain language, present always the data accurately in a way that is proportional to the data has been representing, showing a right amount of information to inform, to get an idea of what the story is, and then discuss uncertainty and explain that uncertainty and explain what it means. And if the uncertainty is extremely relevant, as in that case, reveal it and show it, and then change your title, obviously, if your title is wrong. And then, I believe that that's also very important, right? Demand these from others. As the same way that you demand these from other scientists, you can teach the public to also demand these from scientists and also from journalists as well. So that is what Visual Trumpery is about. Thank you so much.
Great. Alberto, thanks very much. We're running a little over time, but I would like to take 2 or 3 questions if there are any that people want to come back to Alberto on.
Thank you very much. That was just very...
Thank you. Well, thank you.
Going once, going twice. Wow.
I think we can encourage regular people to demand.
In one-on-one conversations. It's like, in my own experience, the only way to convince people that these ideas are important is if you discuss them at home, with friends, with families, in casual conversations. When you discuss a news story that you have seen, use those opportunities to help other people. That's the way I learned. I am not formally trained at all in any of these, not even in graphic design. I taught myself graphic design, right? I'm a journalist. I'm not an expert on anything, right? So the way that I learned was thanks to people like you all, right? Who throughout the years, in casual conversations during conferences, pointed out stories that were wrong, and they explained to me why they were wrong in plain language, right? And then doing reading myself, obviously. But what helped the most was those conversations. Yeah.
Yeah. Let's take a question right here, and then we'll go there next. Okay.
Thank you for the talk. The DACA comparison, when you were comparing to the people from US, that was a voting age people. So are the age groups or the
Which
people?
one? Sorry, say that again.
So the DACA comparison.
Oh, the DACAs. Yes. Let me go back to that one. Yeah, go ahead with the question.
So you were comparing the US population of voting age people and the DACA population, which age is not known. So if you're comparing apples to oranges,
yes,
you will probably get a different number.
There are many limitations on this very quick comparison, and that's not the only one. Right? Let me address them so we can discuss the things. First of all, this is a very quick comparison that I made to put the data in context. If you want to do it right, you will need to get people who are American citizens who are convicted of crimes and who are between the ages of DACA recipients, which is up to 30 years, for example, right? So you need to limit your data up to the same thing so you can compare apples to apples. Moreover, another thing that skews the data I didn't discuss is that these people are counting not just convicted criminals. There are also people who are accused of a crime. Right? And here, on this other hand, I am only counting people who are convicted of a crime. So the data is sort of not complete in both ways, right? What I'm trying to point out is that this kind of comparison is important to do mentally, right? To put all these ideas in, these data in context somehow, in both ways.
Okay, thank you.
Okay, so my question is, when it comes to data literacy, do you find that interactive graphics provide a better rate of literacy than just static graphics? If so, why do you think that is, or does it just confuse the message?
I guess that it depends. I have seen, for example, wonderful explanations, wonderful animated and interactive explanations of statistical concepts that are done interactively. But when it comes to messages that are simpler, like basic comparisons between rates or between uncertainty levels and stuff, usually a static graphic will do a much better job. In general, people don't tend to click on stuff or interact with a graphic unless that there is a very good reason to. Right? Unless that there's a very good reason. So my own strategy whenever I'm going to design a graphic is to minimize interactivity as much as possible. And then if I'm presenting the graphic on a mobile screen, have people just scroll so they can get all the information just by scrolling up and down rather than have to click on tons of different stuff. But it depends.
Okay. Alberto, thank you. Okay, I think we're out of time and we're going to move on. So thank
Okay,
you so
thank
much.
you so much.